Alright, so for today I want to do this circuit here. And the unique thing about this circuit is that it has resistors in parallel and resistors in series. So I'm going to go ahead and draw this and then we can talk about what you do with these kind of series and parallel resistors. Now that we've got this drawn, we need to simplify the circuit. The first thing we're going to do is look at this parallel resistor branch here with the 40 and the 10. The formula for figuring out the resistance of parallels is 1 over the required that you're looking for is equal to 1 over 40 plus 1 over 10, which these are the two resistances from the resistors. What you're going to get here is 1 over 8. And then when you flip both of these around, you find that the required resistance is equal to 8 ohms. So now this part right here can be rewritten into 8 ohms. Let's go ahead and do the next section right here, which is the 60 and the 120. We're going to do the same thing. And then you find that you get 1 over 40. And then this is equal to 40 ohms. Basically, you don't really even have to write this 1 over required stuff. As long as you do this part and you find whatever the denominator is, it's going to be that. So if you notice 1 over 8 here, 1 over 40 here, that's just how that's going to be. So we know that this branch right here is going to be 40. Now I'm going to rewrite this with the new resistances and show you that. Now we have the circuit here. So if you look at the top, we can see this 40 and 10 became the 8, which we found, and the 60 and 20 became the 40, which we found. Now that we're done with the circuits in parallel, we can do the circuits in series, or the resistors in series. That would be the 12 and 8 together, and these two are just going to be added together, 12 plus 8. You get 20 ohms on this branch right here. So we can further simplify this circuit. Here is our final circuit. This is simplified. Now what we can do is we can take this and put it into Simulink. You could have done this up here, but it's much easier just to make a simplified circuit, and it's also good to know just how to simplify a circuit. All right, let's go ahead and go to our browse library and start to build our circuit. Okay, let's grab our resistors and start to build our circuit. Now we have to grab our sources. We need a 3 milliamp and a 2 milliamp. Okay, we've got our circuit labeled. Now let's go and see what we need to do. So this problem here wants us to simplify the circuit, which we've done. And we have to determine the power supplied by each current source, and then determine the power received by the 12 ohm resistor, which is going to be up here, not the fully simplified one. So we're going to have to go back. For this problem, we need to determine the power supplied. So that means that the power is going to be equal to the current times the voltage. And in order to do that, we're going to have to find the node voltages of node 1, 2, and 3. And then we can take the current and the voltage there because we have the current here, 3 milliamps and 2 milliamps. So once we find the voltages at the nodes, we can multiply those together with a product block, and then it will give us the power. In order to get the node voltages, we've done this in a previous video, but you need a voltage sensor with the positive hooked up to the node, the minus grounded out, the PS Simulink converter, which goes to your display, and then that will give you a readout of your voltage. Something else that I forgot to add is also we need a ground here at the bottom of our circuit, and then we also need the solver. And this should give us a reading here for this first node. Nice. So what you can do is just copy, and then you can paste each of these onto each node to get the voltage. So now we're going to do the two current sources because we're going to need this. And for the current source, you just run the wire through it. And then you remove the additional part. That way the current only goes through the sensor. And then when we read this out, we should get 0.003, which we do. Okay. Now we'll do it for the next one. There's our 2 milliamps. So now that we have the voltage and the current, we can use a product block to find the power. In order to do this, we can find the product block right here. And we're going to remove the connection from this display. We're going to run it into here. So essentially we're going to run the output of the volts and the amps into the product block. So now we can link up these blocks together, run them, and then we're going to get 0.00732 watts, which is correct. And then over here, we're going to do the same thing. So we can go ahead and copy this bunch of stuff here. And then what you do is remove the displays, and then where the output arrow connects to the displays, you're just going to run both of those into the product block. So we're going to take the output of the amps, put it into here, and we're going to take the output of the volts and put it into here. We're going to run this. We should get 0.000456. That's correct. So this is the first part of the problem where we determine the power supplied by each of the current sources. Because power is the current times the voltage, and the voltage we found here, and then the current is through this source. And these two run together into the product block, and it gives us our answer. The last thing we're going to have to do is we're going to have to find the power received by the 12 ohm resistor. For this, the only thing we need to change is we need to go back up to this drawing here where we broke apart the 12 and the 8, and we can just put another resistor here, and we can change this to the 12 ohm. And then make this the 8 ohm. Now, this part we need to determine the power of the 12 ohm resistor. So the formula for this is going to be P equals I squared times R. So the first thing we need to do is we need to get the current for this wire here going to the 12 ohm resistor. So we're going to go ahead and grab our current sensor, run this through like that. Going to grab our Simulink converter. And then we have to grab a display box. We should get a reading of 8 here. Yes, okay. Now that we have this, we need to square it and then run it into a product block with our resistor. Now that we have this set up here, we want to find the power going through, so that's going to be I squared times the resistance. So for the resistance, what we can do is we can find a gain block. And the gain block just multiplies whatever you want. So we're going to multiply this by 12 because it's going to be the ohms. So I squared times 12. And then we can have a display block here. And this is going to give us our power going to the resistor. And we're looking for 7.68 to the negative 6. That's exactly what we got. Now let's kind of go over everything that we've done because we kind of did a lot. The first thing that we did was we simplified our circuit. We went from the circuit here with the 40 and 10 in parallel, and we reduced that down to 8. Then we took the 60 and the 40, we reduced that down to 40, or the 60 and the 120, sorry, we reduced that down to 40. So we ended up here at this circuit. After that, we took the resistors in series and we add those together, so we get 20 here. Then we moved from this into Simulink, and we built this circuit here. Now this circuit, we found the voltage here at the node, and then we found the voltage here at the second node, which is going to be these two. The question asked us to find the power supplied by each current source. So in order to find that, we need to multiply the current times the voltage. So we have our current right here. Now we know it's 3 milliamps, but we need to have that output in a way that Simulink can use. So we use a current sensor here, run it through here. We also take the voltage from the node and we run both of those into a product block. Kind of give you the name of everything here. So the product block will output the multiplication of the current and the voltage, and we get our display here. We had to do that for the other current source where we needed to find the power as well. So we took the voltage of this node here, and then we took the current from this source of this wire, multiplied that through a product block as well, got this here. After that, it wants us to find the power of the 12 ohm resistor. And then to do that, the formula is P equals I squared times R. So we use a current sensor here on this wire to find the current going into the resistor. So we use that and we multiply it by a magnitude squared block. So we're going to run it from into here. And then we use a gain block to multiply whatever the output is from the square. And then we display that here. There's a bit of stuff going on. This is one of the ones that might be simpler to do by hand, but it's good to know how to do everything because there are going to be some situations where circuits are going to be very complicated and you're going to have to break them down each, kind of like into each branch, do the branch, analyze it, and then kind of move to the next one through Simulink. And it's going to get messier the bigger they do it on paper, and it'd be a little bit easier. There's a lot of other tricks you can do where you can have the outputs get assigned to a tag, and then you can have that tag read out on a display completely separate. So you can have a list of readouts that are not connected by a bunch of wires. It's kind of like wireless, basically, is what it would look like on here. So eventually we'll move towards doing that, but just so we can see how this is done. And this isn't too crazy, but the more complex the circuits get, the more need we're going to have to utilize the wireless version of how to get readouts. But that is all for this video. If you have any specific questions or anything that you're working on that you might need help with when it comes to Simulink, let me know. I'll take a look at it and see if I can figure anything out or if you have any particular questions about a problem. So thanks for watching. If you enjoyed the video, like and subscribe and stick around for more Simulink.